Graphing radical functions is pretty straightforward if you can remember some of the other techniques we've used in the past. So we want to start off with just your basic parent graph, which starts here at 0, 0. And again, we want to think about taking the perfect squares that we have here and putting them underneath the radical. So 1 squared is 1. All right, I'm going to shift over here. 4 squared is 2. Oh, sorry, square root. And the square root of 9 is 3. So those are perfect squares. Square root of 1, square root of 2, square root of 3. And then I can connect all those points. Again, this is just kind of eyeballing it. And this would be my basic square root of x function. Now we can do a few different things in terms of shifting those around. So if I want to just shift down all of these points, say by 2, so I'm going to go and take this first coordinate and go down 2. Right? This coordinate is going to go down 2. I'm going to take all of these points that I have and shift them down by 2. Right? Then what I have now is I have another function. Right? There's another root function, but this is the square root of x, where I've shifted down by 2. And so when you think about these graphs, right, the k value, because it just shifts up and down, all it does is change the y value down by 2. Now, if I want to move these over some, say I take all these coordinates and I move them to the left by 1, right? So instead of being here, it's going to move to the left by 1. Right? And so all of these coordinates are going to go now to the left by 1. And then try to connect them. All right, now what's happened is the x value has changed. And so this would be the same thing as the square root of x plus 1. And so you need to remember that when we're messing around or manipulating what's happening with the x, it's always the opposite. So for example, if I were given this function right here, this x plus 1, and I want to say what is my domain of that function, I would take the x plus 1 and set that to be greater than or equal to 0. And then when I solve and I move this term over, I get x has to be greater than or equal to -1. And that's why we're starting here at -1. So again, every time we have a value underneath the radical, as we've seen in other graphs, it's always the opposite direction of what we see because of how this property works. So if we're going to move to the left, we actually need to write it as a positive. Right? And so these are the different manipulations. Again, I could do extra by changing my a value. But we're going to see is we want to just look at this general idea and then graph a function with all of its characteristics and manipulate the in-out table with our values for a, b, h, and k. Right. So let's just shift this up for a second. And let's say I want to be able to graph specifically y equals 1/2 of the square root of x plus 4 minus 3. Oops. So I want to graph this function. Right. So I'm going to start by making a general in-out table. Right. The values for x and the values for y, and I'm going to leave myself some space on either side of those. And for the moment, I'm just going to use my perfect squares, my 0, 1, 4, and 9. So we'll start with just those values. Now you need to remember how this worked before. If I'm just looking at my parent graph, all right, the square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2, and 3. So this is my parent graph in-out table. All right. Anything happening to the outside of my radical happens to the y. So this is on the outside of the radical, outside of the radical. So just as we had done with trig functions, to this output, I need to perform the order of operations of multiplying by 1/2 and then subtracting 3. Right. And so the order of operations take precedence when you're attached to the y values. So this is going to shift the graph down by 3. And now this is going to be 1/2 minus 3, which is a negative 2.5. Right. This is going to be 1 minus 3, which is a negative 2. And this is the same as 1.5 minus 3, which is a negative 1.5. So we can look at these values here, right? And you can see how they're all manipulated. You can keep fractions, that's fine. And then you also have to remember now, just like I showed you on that last x plus 1 radical, whatever is happening on the inside here, you're going to do the opposite. So I really need to subtract off 4 from all of these terms because it's really going to move to the left. Again, and you can see that if you go off to the side and you actually say what happens when x plus 4 is equal to 0. I'm going to be subtracting off 4 to get my new location. Same thing with this one. If I say what happens to x plus 4 when it's originally equal to 1, same thing. I'm going to be subtracting 4. So your operation is every time subtracting 4 when you set that value equal to the 0, 1, 4, 9. Right. So that's going to make my new locations negative 4, negative 3, 0, and 5. So we'll graph this first, and then we'll look at some of our different values. All right, so I need an x-axis that goes to 5, and I need a y-axis that's down lower. All right. So let's go right here. So 1, 2, 3, 4, 5. So I'm just going to make each line one increment and try to space those again. 1, 2, 3, 4, 5. All right. So now what I have is I need to start my first coordinate at negative 4, negative 3. Oh, I needed some values over here. Oops, just didn't make my graph big enough. So 1, 2, 3, 4. All right, so negative 4, negative 3. So negative 4, negative 3. And then I need to be at negative 3 and negative 2.5. So we've got negative 3. This is negative 2. So negative 2.5 will be about right there. And then 0 and negative 2. And 5 and negative 1.5. And so again, you want to start, try to run through those, and then give yourself an arrow. And you want to make it look a little bit arced. It's not, it doesn't have to be perfect. But we have some information here. We have our point of origin. And that's going to be at negative 4, negative 3. Okay, I've got my domain, which is going to be at negative 4 to infinity. In this case, my range is going to be negative 3 to infinity. Right. And I do have x and y intercepts, but it's going to take some algebra to do those. I can clearly see my y-intercept. My x is going to be way far down there, so I'm going to hold off on that for a minute. And I'm just going to look at this general information. Other little key things is that my translation, my vertical translation, I actually went down 3. And my horizontal translation means I went to the left 4. So a couple little translation information. And this is what you're going to do, very similarly to what we've done in the past with other graphs. Right?